Hey class, today we're going to do chapter 5, the skeletal system, and this will actually be the last lesson in the first half of the skeletal system. I split this chapter into two parts, so you'll have two tests on it, and this is going to be the last one before the first test. In this section, we're going to talk about the developmental aspects of the skeleton, so from birth to adulthood. Some of this stuff is going to sound familiar because we did talk about it a little bit when we talked about bone formation, but we're going to kind of build off of that. So our first long bones when we were a fetus were made up of hyaline cartilage, and then our earliest flat bones, which are located in our skull, were made up of fibrous membranes. And as we talked about with the bone development section, as the fetus grows and gets older, all of these bone models, this hyaline and fibrous membrane, are going to be converted into bone. So here we have a picture of a 12-week-old fetus, and it's showing here that the darker areas is where ossification has occurred. That term ossification just means where cartilage has been converted into bone. Now, a couple things that we need to talk about in terms of a fetus is its skull. That's one of the big differences between an adult skull and the skull of an infant or fetus, and they have something called fontanelles. These are spaces between the bones of the skull in an infant or a fetus where ossification has not yet taken place or been completed. Oftentimes, you might hear people call these things soft spots. Now, soft spots are very important for two reasons. The first one is it allows the skull of a baby to be compressed during birth so that it's able to fit through the birth canal. So if I go here, I'll go to the other slides and show you after I'm finished. The second major region is it allows the brain to grow during pregnancy, so the infant's brain to grow during pregnancy, and even after it's born during infancy. Typically, fontanelles are going to keep around and they will not close and turn into bone until about 2 years of age. So here's a picture typically for a normal skull. All these bones are fused together. It's completely bone. However, for babies, we get these little gaps or parts of fibrous membrane that's not yet converted into bone. And here we have an anterior fontanelle. So towards the front, we have a posterior fontanelle. Here in the back, posterior meaning behind. Another one that we see is a sphenoidal fontanelle over here near its temporal lobe. And then a mastoid fontanelle kind of down here. Now, when I say one of the big important reasons for fontanelles is for the ability for the head to be compressed during birth. Sometimes you might see some babies when they are born come out and have more of an egg shape. So here is an example of a baby whose head had to kind of compress and change a little bit in order for that baby to be properly birthed. And it kind of shows an egg shaped. However, one thing to know about these fontanelles is it does reset or go back to the position it should be in. So here is a baby's head about 24 hours after birth. The other thing that I want to point out is that when you have children, especially infants, tummy time is very important. You might have heard moms talk about this or any kind of adult. You may have heard it in your child development parenting class with your teacher. But tummy time is important because when you always have a child laying on their back, they're doing a lot of stress or pressure on the back of their head. And over time, that can lead to a child having a flat head. And they don't want this because they want the cranium or the head to have proper development because we're going to learn here in a few slides that is important for brain growth. And so we want to make sure that they have proper tummy time so the head develops properly. Now, why does it do this? Again, it's because those babies have those soft spots that are easily subjected to pressure or can shift around and move because of pressure or factors like that. Now, why do we want the baby's head to be properly proportioned? Why do we want to make sure that it's forming properly? It's because the growth of the cranium or the growth of the skull after birth is related to brain growth. We want to have a proper skull so that the brain is able to expand and grow. Sometimes, if these fontanelles or soft spots ossify or turn into bone before the 2-year mark or before they're supposed to, if they do it too early, that can lead to issues with brain growth. Another thing that I want to point out for the skull is that oftentimes the skull, we have our facial part of our skull. And facial skeleton is going to increase for 2 reasons. And typically, we see the facial skeleton kind of come out when you start turning like 5 years old, 5, 6. You kind of see the different shapes taking place in a children's skull. And this is because it allows for tooth development, and we want to enlarge or make our respiratory passageways bigger. This is not in your notes. I will not ask it on a test, but this is just some kind of cool information. You do not need to write this down, but this is the size of the cranium in relation to your body. When you are 2 years old, the skull is about 3/4 the size of an adult skull. When you are about 8 or 9, this is when your skull is going to be near the size of an adult skull in size and proportion. So once you typically get about 8 or 9 years old, your head doesn't usually get much bigger. And then about ages 6 to 11, this is where your face is going to start growing out from your skull. Again, this is because of tooth development, and we want to also open up their respiratory passageways when we breathe. Now, over time, we're going to see different skeletal changes. At birth, the head and trunk are proportionally much longer than the lower limbs. And as you age, you're going to see the body proportions change. I do have an image coming up later in this lesson to kind of show you how the proportions of a child compares to an adult. A couple other things to talk about is we often see developmental changes during puberty. For example, this is when females' pelvis tend to broaden because they're getting ready to prepare the body in hopes that eventually a female will have a child and carry it. The second thing is male skeletons tend to become more robust. The last thing, and we've mentioned this a couple of times when we talked about epiphyseal plate and we talked about bone formation, is this idea of the epiphyseal plate will eventually become fully ossified or turn into the epiphyseal line by the end of adolescence, and that's typically when they say that your growing is complete. So you shouldn't grow much taller. Here is the differences in growth rates for some parts of the body compared to others. So on the left, we have a picture of a human newborn. We kind of don't see that face protruding out in our bones. We tend to see these open spaces, our fontanelles that we talked about. Whereas a human adult, all of those fontanelles have ossified or turned into bone. And then we see more of a protrusion of that face. This picture right here shows body proportions. So when you are a newborn, you can kind of see that your head and torso, right from here to here, is a lot longer than your limbs. Where when you become 2 years old, that starts to lengthen. It continues to become more proportional. And then when you become a body or an adult, your body is a lot more proportionate. And last but not least, older adults. I could not get away from the skeletal system without talking about one of the major diseases that affects bones in people, and that is osteoporosis. Osteoporosis is a bone-thinning disease. It affects about 50% of women over the age of 65 and about 20% of men over the age of 70. This disease makes bones fragile, and what that means is the bones are more susceptible or can easily fracture. And we talked about this when we talked about bone fractures. The older you get, the less density and bone mass that bones have, and that's why they become fragile. Other things that can lead to the development of osteoporosis is if you have a poor diet. That is also going to prevent. So make sure that when you're little, you're getting the proper nutrients, specifically calcium and phosphorus, and you get a lot of vitamin C. Another vitamin that's very important is vitamin D, because vitamin D helps make sure that we can take that calcium and deposit into bone. Smoking will also affect the bones. And then also, you want to make sure that you have sufficient weight bearing exercise. If you have insufficient weight bearing exercise, that's going to be more of a thing that will cause you to have osteoporosis, because you're not building up that bone. You're not subjecting it to friction. You're not subjecting it to any kind of stressors that would make that bone remodel and strengthen itself. So we want to make sure that we are getting sufficient enough weight bearing exercise. One of the common things that happen when you have osteoporosis is you tend to see a vertebral collapse. Vertebral, we just mean your backbone. And this results in a type of symptom called kyphosis, also known as dowager's hump. And that's when you kind of see a hump in the back of the neck of somebody. Typically, this does happen because of osteoporosis, but it's now becoming a very commonplace because of poor posture, of people always hunching over phones, hunching over computers, hunching when they sit. So we tend to see this, and I do believe I have an image coming up on it. So here we see kind of that hump in the back. That is your dowager's hump. The last thing to talk about is, with this idea of osteoporosis, estrogen is very, very important for a woman specifically, because it helps aid in proper health and normal density of the female skeleton or bones within the female. And that's the end of today's lesson. If you have any questions, please make sure that you ask. And I hope you guys have a great day.